Okay, let's look at the practice exam 3, problem number 3. Right? So let's do that. So number 3, we want to sketch the graph of this given function. Right? Part A. We want to find the derivative. Right? So let's do that. So f prime of x is equal to, right? So you have two things multiplied together. So we have to use a product rule. So that's the first guy. So that's the second guy. Right? So derivative of the first guy is 1 times derivative of the second would be e to the negative x, right? Plus first guy is x times the derivative of the second is e to the negative x times derivative of negative x would be negative 1, right? So which is going to be, right? So you have e to the negative x, right? Then you have 1 minus x, right? So that's the derivative that we're looking for, right? So f prime of x, right? Then we can find a critical number by setting that equal to 0, right? Then here, since e to the negative x is never 0, so we can you can divide through by e to the negative x, since this is never 0. So you get the 1 minus x is equal to 0. Alright, then which means that x equals 1, right? So you have x equals 1. Right? So this is the critical number. Right? So we found the critical number. Alright? Then part B. Right? It says that to find the second derivative, so we can do that. We can simply take another derivative, so f double prime of x is equal to, right? So derivative of the first guy would be e to the negative x times negative 1. So I'm going to put a negative sign in front, right? Times the second guy, which is quantity 1 minus x, right? Plus, right? First guy is e to the negative x times derivative of 1 minus x would be negative 1, right? So you can see that still you have e to the x, and the e to the x is in common. So I'll pull that out. E to the negative x, I should have said, right? So here e to the negative x is factored out. E to the negative x is factored out, and what's left is, right? So it's a negative sign. So negative times distribute to negative x will be positive x. Right? And a negative sign is distributed to negative 1, so that's negative 1. But there's another negative 1 right here, right? So it's going to be negative 2, minus 2, right? So that's the second derivative, right? Alright, then we want to find the inflection point, so we set the second derivative equal to 0, right? And from there, same way, again, e to the negative x is never 0, so you can just divide through by e to the negative x to get x minus 2 equal to 0. Then we can just add 2 to both sides, so we have x equals 2. Right? Let's make sure that at x equals 2, there's a concavity change. So we're going to just do a number line, right? X, and here is 2, right? Then let's look at the sign of f double prime, right? So let's try something smaller than 2. So let's try x equals 1. You can see that the 1 minus 2 is negative. e to the negative x is positive, so it's going to be negative here. All right? And after 2, we can try x equals 3. So 3 minus 2 is positive. E to the negative x is positive. So you have a positive sign here. Right? So original function f is actually concave downward before 2. After 2, it's concave upward, which means that there's a concavity change at x equals 2. So there's an inflection point at the x equals 2, right? So we need to find the corresponding y value. So just plug in 2 into the original function. We get 2 times e to the negative 2, which is 2 over e squared, right? So inflection point that we were looking for would be at 2 comma 2 over e squared, right? So that's the inflection point, right? So you got part A and part B. All right, part C, complete the sign table below using this. We meant this should be A, part A, and part B, right? On interval, let's see, where f is decreasing and concave up. Right, so let's do that. Do the table first. Right, so before 1, we said that we can try something like 0. Plug in 0, it's positive. Right, after 1, so like try 2. 1 minus 2 is negative, so that's negative. So it's negative here, also negative there. Right. For the second derivative, we know that the before 2 it's negative, after 2 it's positive. So before 2 it's negative, so negative here, negative there, negative. So after 2 it's positive, right? Then second part of the question is find the interval where f is increasing and concave, decreasing and concave up, which means that the decreasing means the first derivative negative, and a concave up means that second derivative positive. So only place that would be right here, right? So answer is so f is decreasing and a concave up at the same time on the interval from 2 to positive infinity. All right, so we have that. All right, then part D, based on what we have and then maybe a couple more points, then we want to sketch the graph of y equals f of x. All right, since we don't have a lot of room, I'm going to slide down a bit. All right, then sketch the picture. All right, so let's do that. All right, so the graph is going to be, so I'm going to draw x-axis around here. All right. Then y-axis around here. All right. All right. Let's try to find, say, X intercept, then the y intercept. Say X intercept. All right. If you want to find X intercept, what we want to do is set y equal to 0. So we're going to set f of x, which is x e to the negative x equal to 0. Right, but again, e to the negative x is never 0, so x equals 0. Right, and the y-intercept, right, is going to be actually the same, but you can plug in, set x equals 0, so we get 0. Right, so we know that it's going to go through the origin, so it's at 0, 0, right here. Right, so here's x-axis and here's the y-axis. Right, another point we can put is an inflection point. We found that from part B, so I'm going to put inflection point. So 1 here and 2 here. All right, so 2. Alright, so you have a 2 over e squared. So I'll just put some point around here. Alright, so it's a 2 over e squared. So I'll just put the dot, 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 dot. Right, so dot, 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 dot. Right, so this point is going to be our inflection point. Right, and also we have a critical number. Critical number is at 1, so maybe we should find a point corresponding to that. So x equals 1 is here, so plug in f of 1. Right, so that's going to be 1 e to the negative 1, which is going to be 1 over e. Right, so 1 over e is slightly larger than 2 over e squared, so I'm going to just put somewhere around here. Right, 1 over e. So this is going to be the point. Right, so that's going to be the point at the critical number. All right, so let's try to follow the shape and make sure to go through here. All right, and let's see. Oh, actually, one more thing we can find is the horizontal asymptote. Right, horizontal asymptote can be found by taking a limit of the function x e to the negative x as x approaches positive infinity, and you can see that this is just a limit x over e to the negative x is 1 over e to the x as x approaches infinity. Right, we know how to do this because top goes to infinity and the bottom guy goes to infinity, so we can apply the L'Hopital's rule. Right, so if you apply L'Hopital's rule, maybe you're going to go down here, so I'm going to just slide down a bit, go down here. Right, L'Hopital's rule. Right, so you're going to have limit as x approaches infinity of derivative of x is 1, derivative of e to the x, e to the x. Right, as x approaches infinity, e to the x goes to infinity. 1 divided by big number is going to approach 0. Right, so y equals 0, which is the x-axis, is the horizontal asymptote. So horizontal asymptote is right here. Right, so let's sketch the picture. Right, it says that before 1, it's increasing and concave down. Right, so here it's increasing and concave down. So it's going to look probably something like this. Right, and between 1 and 2, it's decreasing and concave down. So here, so it gets flat there, but it looks like this. Right, and after that it's a decreasing and concave up, and you have to have a horizontal asymptote here, so it's going to be decreasing and concave up, so it's going to look like that. Right, so that's the graph of y equals x e to the negative x. All right, that's it. I hope that this was clear.